Hey everyone, Chris Mattson here. I'll be the first to tell you that the front cover of the Braun ET66 calculator is a challenging project to jump into. That's why I'm going to guide you through it, starting with this video, which is about how to gather the information you need to create a CAD strategy. Let's do it. In any design setting, the first thing you need to do is to understand what is required of you. This may involve talking to people or reading materials such as memos or other things, or simply internalizing the task that you're given. Since you're using this guidebook in your training, your assignment that you need to do is to create a portion of the ET66 calculator by Braun. In fact, you're going to make the complete front cover of the ET66 calculator. To do this successfully, you're going to need to learn to read and understand engineering drawings. For many of you, reading these kinds of documents is new and is going to be very difficult. So I'm going to give you some tips to help you through the process. Tip number 1, start with sheet 1. Now, the ET66 calculator has 6 sheets in the engineering drawing. Start at sheet 1. Usually sheet 1 has some overall information that will be useful for you. It will have the orthographic projection, views, and an isometric view. If you don't know what these are, feel free to go right into Google, type those things in so you can understand what they are or recall reading about them in the guidebook. Part number 2, read and pay attention to the title block. Specifically in the title block, we have things such as the units that the drawing is in, the materials, and the finish. This information will help you during the modeling process. Also notice that the title block is the same for all of these sheets in the drawing. Tip number 3, notice and pay attention to the notes on each of the sheets. Each of the sheets has its own set of notes, and these notes are meant to clarify views or other important things on that sheet. Number 4, pay attention to the section views in the drawing. A lot of information needed to model this part can only be understood from the section views. A section view is produced when we cut a part on a line and then look at the inside of the part where we cut it. To make the drawing simpler to read, the section views provided in this drawing set are only very thin slices that show the part only where we cut it. Section views look in the direction of the arrows on the sectioning line. On sheet 5, notice that sections come in a couple of varieties. They come in the straight line variety, as shown in section AG, and they also come in the disjointed variety, as shown in section AI. Now notice in section AI that the cut follows a horizontal line for most of the part until it jogs up to another horizontal line near the right side of the part. We need to pay attention to the section views. So much of the detail in these drawing sets comes from the section views. All right, tip number 5, pay attention to the detail views. Just like we had to pay attention to the section views, we also have to pay attention to those detail views. A detail view, for example, detail Q on sheet 2, is a zoomed in view of a portion of the part. The area of the detail view is generally indicated by a circle with a letter near it. Then on that same sheet or on another sheet, an enlarged view of that area is shown. Now, because of the geometry of the ET66 calculator, some of the detail views are hard to spot, such as detail W, Y, and Z on sheet 3. Okay, and the last tip that I want to give you here is that the feature heights are defined in the section views. So use those section views to define this. Now, as you're modeling this part, one of the greatest challenges associated with it is figuring out the height of all these features, the height of those poles, the height of those ribs that are on the underside of the front cover. The section views indicate these heights. Many of these feature heights are the same, as can be seen visually, or as indicated by the number of instances. For example, 13x, which means there's only one dimension on this drawing that applies to 13 identical cylindrical extrusions. You may also note this symbol in the drawing, which is an indication of how deep a hole is. I spent about 5 to 10 minutes reading the engineering drawings, and looking through them before I sketched out my CAD strategy. When I was examining these drawings, I was not trying to memorize anything or run any calculations or anything like that. What was I doing? Instead, I was trying to visualize the part in 3 dimensions so that I could take that complex geometry and break it up into simpler shapes that could be easily modeled in the CAD system. For example, amid all the complexity, I could see this shape when I looked at the drawing. Or as another example, I could see these features as simple rectangular extrusions. I also looked for patterns and details, such as the buttonholes simply being a pattern of one cut, or the details around the LCD window, in terms of there being 2 different chamfers. Okay, these were the kinds of things I looked for as I spent 5 to 10 minutes with the engineering drawing, just trying to absorb it and understand it. Why do these features matter so much? They matter because they drive the CAD strategy. They drive the sequence of steps that we're going to use to create the solid CAD model. All right, that wraps it up for this video. In the next video, I will show you my CAD strategy and how I sketched it out, what I thought about while I was getting that strategy together in preparation for modeling this part.